All right, we're going to look at today using um, quadratic equation and solving methods to find the solutions that oftentimes come out to be complex solutions. All right, so this first one, they want us to solve out and find the answers to this quadratic. Now on this one, notice that a lot of times when we have a quadratic, it is in this standard form here that looks like this. This problem has no b term. It's the b is 0, so that one's not there. If you don't have that b term, you should just be able to go through and solve the equation because there's only one x in there like you would anyone. So in this one, we would start by subtracting 36 from both sides. So now we got x squared equals negative 36. To undo a power of 2 now, we want to square root both sides. And recall when you're doing this, it's going to be plus or minus the square root on this. So we got x being equal to plus or minus the square root of negative 36. Now, before when we did this type of problem, we would say no solution. And we're partly right there because we can't do square root of a negative and get a real solution. But as we've seen over the last couple of videos, there is a complex or imaginary solution to this one. So what we're going to do now is take that negative under the square root and turn that into an I. And so we have plus or minus I square root of 36. And square root of 36 is 6, so the answer to this one is plus or minus 6i. You can write it as I6 too. Usually the coefficient's written first. So that would be the answer to this one. If they actually did want you to write it out in a plus bi form, then you would just throw a 0 on there, 0 plus or minus 6i. Depending on how they want you. Plus or minus 6i is probably fine though too. All right. Next one. This one now has both A, B, and C on it. So on these types of problems, you have to go a little bit further here. So you can't just solve by subtracting 5 and doing that kind of stuff because we got x and x squared. You're not going to be able to take a square root of that. So on these types of problems, that's where we do want to go through and do quadratic formula. And if you don't recall quadratic formula, that is where we got x equal to opposite of b plus or minus the square root of b squared minus 4ac all over. The whole thing's over 2a. So on our problem here, we want to find out what is that a, b, and c. Here our a is 1 because there's a 1 in front of that x. B is 4 and c is 5. So now we're going to put that into quadratic formula and see what we get. So we got our answers are going to be the opposite of b plus or minus the square root of that same b value squared minus 4 times 1 times 5 all over 2 times 1. The first part and the bottom are usually very easy to simplify, and here is no different. 2 times 1 is 2. We got negative 4 and plus of that in front of that plus minus symbol. What about the square root, which is called the discriminant in this? Well, 4 squared is 16 minus, if we multiply 4 times 1 and 5, that's 20. So we end up getting 16 minus 20 here, which is going to simplify all the way down to square root of negative 4. Now, again, before we would say at this point, well, we can't take a square root of a negative, no solution. But that in this case, that just means there's no real solution. And it's no, I mean, we can say there's no real solution to this one, and we're not incorrect. But if they want you to find the complex solutions, then you got to keep going because there is a complex solution to this one. So let's turn that negative into an I. Negative under the square root here. We're going to change that into an I. So we got plus or minus I. And then what would be left is square root of 4, and we know square root of 4 is 2. And so now we have this as our complex solution. When we write that out, though, we want to separate the real and the imaginary part. So since this is all over 2, we want to write both that real part and that imaginary part both over 2, because that's our common denominator right here. Okay, so now just simplify both of those and you have the answer. So the answer, negative 4 divided by 2 is negative 2, plus or minus 2 divided by 2 is 1. So the complex solution to this one is negative 2 plus or minus I. That is a solution to this. It's not a real solution. It has an imaginary part to it, but it is the complex solution. Okay, let's try, keep going here, try some other ones out here. So we see that this one has both x squared and x in it. Find all your a, b's, and c's and use quadratic formula again. So a is 4, b is negative 24, c is 37 here. So if we put this into quadratic formula, we got the opposite of negative 24 plus or minus square root of negative 24 squared minus 4 times our a value times our c value all over 2 times a. Okay, so simplifying this, again, the part in front of the plus or minus is easy. Opposite of negative 24 is going to be positive 24. The bottom's easy, 2 times 4 is 8. It's this part under the square root, the discriminant, that usually is where mistakes happen, so be careful with that part. So let's kind of take it step by step here and see what we get. Let's find out, what is that going to be? In your calculator, I would go through and do that part first here. So type it in exactly how we have it. Just don't put the square root in there yet. So we got negative 24, and it's important to have parentheses here because we want to make sure the calculator knows the square of the negative part of that. Minus 4 times 4 times 37. And what we see is we end up getting negative 16 for this. So this is negative 16. All right, so now what we want to do is keep simplifying. That negative in front of the 16 we can pull out as a I, imaginary part. So now we got 24 plus or minus I, and then what's left is square root of 16. Square root of 16 is 4 over 8. Now separate that real part and that imaginary part out. So we got 24 plus or minus 4i. Both of these now are over this common denominator of 8. And then if you can simplify either of those fractions, do it. In this case, we can. With both of these, there's numbers that go into both. On the first one, 8 does go into 24 3 times, plus or minus. 8 doesn't go into 4, but we know 4 goes into both of these. 4 goes in here once, 4 goes in here twice. So with that second part, you'd end up with 1/2 I. So that's how we'd write out the solution on that one. Okay, example 4, a little bit different now in the way they throw this one at you. It's not in that standard form. Remember, standard form looks like this, ax squared plus bx plus c. So how do we get this one in standard form? Because I see here that we have an x in the denominator. Well, what we're going to do here on this one is first multiply through by an x. We're going to times, as long as we multiply everything, both sides by the same thing, that's fine. So we're going to times this side and by an x, but that means we also need to multiply the other side by an x. So here we got to distribute. What do we get if we times everything by an x here? Well, x times x is x squared. X times 5 is 5x. On this next one, if we times this one by x, the x in the denominator and the x that we're multiplying outside would cancel out there, leaving us with just 7. Equals 0 times x is still 0. So now this one is in, this one's in quadratic form. We know what our a, b, and c would be here. A is 1, b is 5, c is 7, and then we want to go through and solve that one. Why don't, on this one, pause the video and see if you can go the rest of the way and use quadratic formula here to find the complex answer. All right, hopefully you've had some time to try this now. Let's see what you got. You should get x equals opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. That's going to give us negative 5 plus or minus 2 on bottom. On top we get 25 minus 28, which is negative 3. Taking that out, it's going to be negative 5 plus or minus I square root of 3 over 2. Separate that out now into the real and imaginary parts for the answer. And hopefully what you got here is negative 5 over 2 plus or minus. And then on the other part, we got square root of 3 over 2i. That would be the complex solution to this one. Okay. All right, let's try one last one. In this one, we have a complex one here. If you have a fraction involved, up to you how you want to handle it. Probably the easiest way I think would maybe be to, like we did in the last one, multiply through to get rid of the fraction. So what we could multiply through here by would be 4. If we times both sides by 4, that would get rid of our fraction, because 4 times 4 is going to end up being, or 4 times 1/4 would end up being 1. So now we'd have x squared minus, but we got to distribute this, so minus 20x. And then we got to do 4 times 36 and see what that would be. Do 4 times 36, we end up getting 144. And then 0 times 4 is still 0. So now you don't have fractions you have to deal with when doing this one. So the a would be 1, b would be negative 20, c would be 144. So if we go through and do it like we've been doing these other ones, now we got the opposite of negative 20 plus or minus the square root, negative 20 squared minus 4 times 1 times 144 all over 2 times 1. That's going to be now a positive 20 over 2. Let's do our discriminant part, that part underneath the square root again. Do it without the square root, so you got negative 20. And again, parentheses are important here, squared, because we want that to come out to be positive, minus 4 times 1 times 144. And that ends up being negative 176. Okay, so how we keep going on this one now, take that negative out and make that into I. So you got 20 plus or minus I square root 176 all over 2. We know eventually we're going to want to, though, make this both over 2 here. So now what you want to do to get to your final answer, because oftentimes, especially like on the ACT, they'll have these simplified. So 20 over 2 is going to be 10 plus or minus. Does that square root of 176 have any perfect squares in that? And you want to check that because they're going to show you the most simplified. So we're checking like, is there a square root of 4, a square root of 9? Those perfect square numbers we know. Do any of these go into 176? Let's just try it on our calculator. What if we took 176? Does 4 go in there because it's an even one? Let's check. Yes, it does. In fact, it looks like a 4 would go in there twice. So it looks like the bigger perfect square that would go into this would be 16. Let's try dividing it by 16. Yep, 16 and 11. So what we want to think of this one as is square root of 16, square root of 11, and we know square root of 16 is 4. 4 square root of 11 is the simplified way of writing that. And so this one now is 4 square roots of 11, still over 2 with I, and so the final simplified answer would be 10 plus or minus 2 goes in here twice, so 2 square roots of 11. I. There's the complex answer for that one. So that's solving quadratics when imaginary numbers come into play and how you write it with a complex number.